Um, Welcome back to another video. In this video, we're going to talk about the actual mechanism of radioactive decay. What exactly happens to the atom when it decays, when it emits alpha, beta, or gamma? We know that most elements have more than one isotope, and many of these isotopes, no, usually one or two isotopes are stable. The other isotopes are radioactive, and they decay away by emitting either alpha, beta, or gamma radiation to become stable. And also the stability depends on um, the number of particles. Okay, if you look at the large nuclei above iron, you'll find that they are, like, for example, uranium has got 92 protons and it's got 146 neutrons. Now, if there are too many protons, now remember the protons are positively charged, and the positive charges, they repel away from each other. Okay, so they will be trying to break the nucleus apart. The strong nuclear force will be trying to bind them together. Okay, now if there are too many protons for stability, the nucleus will break apart by emitting an alpha particle, okay, to get rid of the extra protons, extra positive charge. So this is what happens when an element decays. It gives off alpha particles. Now, if there were too many neutrons to stabilize itself, it emits a beta particle. Now, and we will talk about how beta particle comes about. Let's first of all talk about alpha. Now, if we take an element X, whose atomic number is Z, the mass number is A, it emits an alpha particle, which is the helium nucleus, which is made up of 2 protons and 2 neutrons. So its atomic number is 2. So when it comes out of the nucleus, the atomic number will be left with 2 less protons. Okay, so what is the atomic number going to be? It's going to be Z take away 2. Okay, that's going to be Z minus 2, because there is 2 protons less, and its mass number will decrease by 4. Now remember, 2 protons and 2 neutrons, they have the same mass, so altogether 2 and 2 is 4. The mass number is 4, so that means mass number will decrease by 4. So that will be A take away 4. Now, if we do an example, like radium 22688 decays by alpha emission to radon, okay, and we'll see what the mass number and the atomic number of radon is going to be. Now, remember, this is 88. 2 of these protons, there are 88 protons, so 2 of these protons have come out as alpha particle, so there'll be 2 protons less. So Z minus 2, which is 88 minus 2, which is 86. And its mass number is 226. It will decrease by 4. So 226 minus 4 is 222. Okay, this is how alpha emission occurs. Now that means, you see, one element is changing into another element. Radium is changing to radon. Okay, so when radioactive activity takes place, so when alpha emission takes place, the element goes back 2 places back in the periodic table. Okay, a new element is produced, which will be 2 places back in the periodic table. Now, what happens in beta decay? Now, beta is an electron which is negatively charged. Now, you might say, where on earth did electrons come from in the nucleus? Nucleus is made up of proton and neutrons. But what happens in this case is that one of the neutrons changes to a proton by emitting an electron or as a beta particle. So I can write this. You can think of a neutron as being made up of a proton and an electron. So this is a neutron is equal to a proton, which is positively charged, and an electron, which is negatively charged. So when a neutron changes to a proton, the electron comes off as beta particle. So the electron is given off. Okay, this is the beta particle, which is given off because a neutron changes to a proton. Now that means this nucleus will have one proton more. Okay, remember one of the neutron has changed to a protons, so its atomic number Z is going to increase by 1. So this will be, I'll write it in blue again, Z plus 1. And the mass number, now because the electron has a very, very small mass, it's about 2,000 times smaller than a proton or a neutron, we say that the mass number is almost 0. So it will not be, the nucleus will not be affected because the mass is so small. So it's negligible. So we can say that the mass number stays the same as A. Okay, I'll give an example of polonium-218, 84, decays by beta emission to astatine. Now, what will be the atomic number and the mass number of astatine? Well, the atomic number of this is 84. Now remember, one of the neutron has changed to a proton, so we have one extra proton created. So the number of protons will be 84 plus 1, which is 85. And its mass number, because the electron is so small, it doesn't affect the mass number, so that stays the same, 218. Okay, the third one is gamma emission. Now, what happens in gamma emission? The atomic number, the mass number stay the same. We can write down A and Z stay the same. Okay, because this is just electromagnetic waves, okay, which is just energy of the nucleus changes. Now, usually after an alpha or beta emission, now remember the nucleus is made up of lots of protons which are trying to break the nucleus apart. Now, the short range strong nuclear force is trying to hold the nucleus together. Now, when a big chunk, like say an alpha particle, which is made up of 2 protons and 2 neutrons, comes out of the nucleus, the rest of the nucleus is left in an excited state of very high energy. Okay, and these particles, they jiggle about to try to equalize their potential. Okay, and they get rid of their extra energy as by emitting gamma rays. Okay, so this is what gamma emission is. Okay, it loses excess energy by emitting gamma rays. Okay, because gamma ray is electromagnetic waves, okay, of high energy. So I think this is sufficient for this video. I will see you until the next video.